I would like to share with you something that I've been working on for the past 4 days and that I will be continuing to work on for the foreseeable future. This is a technical and UX description of a solution for managing infection risk in a pandemic scenario in order to facilitate remission while still allowing for a safe level of interactions that are required for the production and distribution of vital goods and services. The need for such a model is based on the premise that prolonged physical isolation for all professional categories is not compatible with the consumption requirements of the general population. It works through a mobile app on the front end and a predictive model by assigning to each person a risk of having contracted the virus based on their interactions and their location history. If you're familiar with the game Minesweeper, you'll find it easier to understand the logic behind this model. It also uses the distributed ledger mechanism found in cryptocurrencies. From this standpoint, interactions are analogous to transactions. To illustrate the model, let's go through a basic chain of interactions. Sam has tested positive for the virus and is now in quarantine. Going by the point in time at which he started to exhibit symptoms, we can estimate that 7 days ago, Sam's chances of being infected were at 50%. Let's refer to the probability of the virus being present in a person or a location as exposure risk. So when Sam was at 50% exposure risk and no symptoms, he was in the car with Tim for 30 minutes. Of course, Tim comes with his own exposure risk since no one is ever at zero in a pandemic scenario. We express Tim's new exposure risk after this interaction as 1 minus Tim's chances of not having the virus multiplied by 1 minus Sam's risk times the interaction distance. For indoor spaces, the interaction distance is defined as the density of people times the duration, or the number of people taking part in an interaction divided by the volume of the space times the duration. The interaction distance expresses the likelihood of the virus being transmitted from one person to the other if any of them are infected. When we calculate the distance, we factor in how contagious a virus is. From the data we have for this virus, we can estimate that spending 20 minutes in a space the size of an elevator with an infected person will put you at a 90% chance of being infected. Back in our example branch, after interacting with Sam, Tim's exposure risk goes up to 40%, and Sam's just goes up by a little bit since Tim didn't bring a high risk to the interaction. Amy is a nurse at the hospital. Due to the high exposure risk of that location, for any 12-hour shift that she works there, she poses a 3% chance of contracting the virus. This means that after 5 shifts in which she hasn't been tested, her exposure risk is over 14%, just from that place. She shared a bus ride with 20 other people. One of those people was Liz. Liz is Tim's husband. They live together and share a 100% chance of inoculation. So if at this point Tim gets tested and the result is negative, the event brings down the exposure risk of everyone he interacted with by a factor proportional to the interaction distance. Tim's negative result makes it less likely for Sam to have been infected when they were in the car together. It also makes it less likely that Amy caught the infection at work. Tim's test result actually triggers a chain reaction that propagates recursively across the entire grid of interactions. This is a simplified version of our distributed ledger, which contains a list of all interactions. We use it to allocate tests efficiently in order to triangulate and pinpoint the virus, and also to manage exposure risk on a person-by-person basis. Whenever someone's risk goes above a set threshold, we can issue them quarantine instructions, and other people will also know not to interact with them. And this is achieved without any degree of stigmatization. Let's look at the app. This is the main screen. Let's start with the QR code. You meet someone, you scan their code, or they scan yours. When you go into an indoor location like a supermarket, mall, church, your place of business, of course, you don't have to scan the code of everyone there. The location will have it displayed so that people can scan it. This way, the model knows who was there at the same time. Of course, if you are particularly close to someone, like if they sit next to you on a plane, in addition to scanning the plane's code, you will also need to scan that person's code. It doesn't matter who scans whose code as long as the interaction gets registered. You have a risk based on the interactions that you've had over the last 2 weeks and another based on your location history. Tapping on interactions, these are the ones that you recorded over the last 2 weeks, and you can see the current risk for each of these interactions. So, an important distinction here is that These risks that you see in the right column are not the risks associated with interacting with these people at the time that you're looking at the app. Here you're just shown the risks associated with the interactions that you've already had, so that you can understand how your exposure was calculated, and also if it happens to go up suddenly by a lot or down, you can look at the list of interactions and understand due to which interaction your exposure risk changed. And some of these people might be your contacts, so people in your social circle, and others might be just people who you get close to in your daily activities, like people who you sit next to in line, on a plane, on a bus, whatever the case may be. You also have the ambiental risk. This is based on the estimated virus density in the locations that you have been at over the last 14 days. It's not the location's current exposure risk again, it's just the exposure risk as it relates to the time when you were there. To find the current exposure risk of a person or location, in order to decide if you're going to have a meeting with them or if you are going to go to a certain location, you can use the search. So before going somewhere or meeting someone, do your pandemic due diligence and search. If you need to report an interaction that you didn't register on the spot for whatever reason, you can do that here. Of course, you have to identify the person by their phone number, so you'll want to ask for someone's phone number to register the interaction. It's advisable to register the interactions as they happen so that the model's response time will be as close as possible to the speed at which the virus spreads. You can report symptoms whether it's for you or for someone else. Based on your exposure risk, reporting the symptoms of the virus might take you over the threshold and limit your access to certain high-density locations like public transportation. So, as I said, there are a number of ways in which the score can go down. You can take the test. It can also go up or down based on the test results of others in your extended network of interactions, because the model is constantly adjusting your risk based on new information that it has about your prior interactions. And your score can go down, of course, if you don't have new interactions, because spending 14 days in isolation will bring your score to the level of having tested negative. You can also report a test result. Again, it's preferable to report the result as soon as you take it rather than retroactively, and the date here just defaults to the present time. Each test should also have a QR code to validate your registration of the result. Some might just have a barcode instead of QR. You can just input the number manually if that's the case. You'll also need to take a picture of the result, which will be randomly assigned to a human who has volunteered some of their time through the app to help with labeling pictures of test results, just so that we can maintain the accuracy of the data going into the model. Lastly, we can report an emergency. So you may require supplies, medical care, or both. Tapping on current location will fill in the address based on your geocoded location. If it gets it wrong, you can correct it in the field. And you should record a short message explaining the nature of the emergency. So just like you would if you were to call an emergency services line in non-pandemic times. However, this has to be done asynchronously. So the first responders will get to your message and play it, but it's unlikely that there will be someone answering every single emergency call in real time. So you record the message, include details that can help the responders get to you, and you can also type it as an alternative. And then your emergency call is in the system, and you can track the progress for it in the alert section. So there's a little bit more to the app, but these are the main sections. Of course, there's a scenario for when you get infected. Okay, so here's the thing. We have the technology to pull this off. We're walking with the technology in our pockets. So if you're a backend developer, a data scientist, Android or iOS developer, there's a link in the description to a Discord server where we can get organized, and I'll also post a GitHub link to a repo and do a first commit with what I have so far for the backend. Get involved if you think this can help.